Welcome to today's Explainer. We're diving right into the ultimate structural blueprint for radiant heating, using the Warmboard S manual as our guide. I'm super excited to walk you through this because this document isn't just a basic list of instructions. It is an absolute masterclass in modern construction technology. By the time we wrap up, you're going to know exactly how those bright red tubes and shiny silver panels come together to literally and silently heat a home. You know, when you see a professional installer laying out hundreds of feet of this tubing, it looks overwhelmingly complex. But as we break the material down today, you'll see the sheer genius lies in a highly engineered, totally repeatable system. Okay, let's jump straight into this chronological builder's journey. We'll be covering introducing Warmboard S panels, essential prep and warnings, slabs and moisture management, routing and running tubing, and we'll finish up with hardwood flooring facts. Part 1. Introducing Warmboard S panels. Let's get a solid understanding of the literal foundation we are working with here. First things first, it is absolutely crucial to grasp that this isn't just a regular piece of wood. We're talking about a highly engineered 95-pound hybrid structural panel that's specifically designed to conduct heat. Picture a hefty 4x8 sheet of 7-ply plywood, but the real magic? It's all on top. There's a highly conductive 0.025-inch thick 1060 aluminum alloy skin, permanently bonded over the entire surface, complete with pre-stamped channels. It's built to bear the structural load of the whole house while simultaneously acting as a massive heat conductor. Pretty incredible, right? Think of these panels like giant modular puzzle pieces. You've got right, left, straight, double, and half-double panels that builders literally lock together to form continuous tubing channels across an entire room. And because it has APA and ICC structural reporting details, it fully replaces a traditional subfloor. By simply matching up the tongue and groove edges of these specific panel types, an installer creates a seamless looping highway for hot water to flow through the entire floor plan. All right, Section 2, Essential Prep and Warnings. We're moving on to job site preparation now because, as any builder knows, missing a foundational rule here can cost you thousands of dollars down the line. The installation manual explicitly calls out 10 non-negotiable installation highlights that are guaranteed to save you time, money, and a massive headache. The manufacturer puts these front and center for a very good reason. If you ignore them, you're basically setting the entire project up for failure before you even pull out a hammer. So you absolutely have to adhere to these golden rules. Take the 275-foot loop limit, for instance. That prevents a complete loss of heat in a specific zone. Then there's the strict 85-degree maximum surface temperature limit. You also have to verify your joist layouts to make sure everything lines up perfectly. Plus, you must leave an 1/8-inch gap on the 4-foot side of the panels to allow for natural structural movement. And about that 85-degree surface limit, that's actually an industry-wide rule endorsed by the Radiant Professionals Alliance to ensure you don't end up damaging your beautiful finished floors. Just imagine finishing a multi-million-dollar build only to hear the floors ticking every single time the heat kicks on. No way, right? This is exactly why this next warning matters so much. The panels have a rigid aluminum channel. If you use non-approved tubing, the outer barrier of that tube, specifically the EVOH oxygen barrier, can actually rub against the aluminum as it expands with hot water. That friction creates a highly frustrating, audible ticking sound throughout the entire house. To avoid that nightmare, you use approved tubing. This tubing basically acts as the circulatory system for the home, carrying the hot water safely and, most importantly, silently through those aluminum channels. The manual lists very specific half-inch PEX or PEX aluminum PEX brands that have been rigorously tested to ensure they sit completely flush and operate quietly within the whole system. Moving to Section 3, Slabs and Moisture Management. Now we hit the gritty reality of the job site, managing environmental challenges, particularly installing over concrete. This perfectly establishes the high stakes of our build. Ignoring slab moisture isn't just a minor mistake, it is a structural death sentence for the panels. Remember, despite that high-tech aluminum surface, the core of the panel is still plywood. So if a freshly poured concrete slab hasn't properly cured, the moisture will migrate straight up into the wood, causing swelling, rot, and irreversible damage. So how do we build a moisture defense? Well, let's walk through a simple yet incredibly vital 16-hour test known as the plastic sheet method. You essentially trap a section of the slab under a clear plastic sheet that's taped down tight. If you come back the next day and see condensation on the plastic, or if the concrete underneath looks dark and damp, you immediately know it's way too wet to install your subfloor. It's a brilliantly low-tech test that prevents a very high-cost disaster.
Now, depending on your insulation needs, you actually have 3 distinct methods to mechanically fasten the panels to a fully cured slab. And listen, you cannot simply glue or float them. No matter which method you choose, you always start with a heavy polyvapor retarder. From there, you can use concrete anchors to fasten the panels directly to the floor. Or if you need some sound deadening or extra insulation, you can put a layer of Homosote down first. Finally, for maximum insulation, you can frame out wooden sleepers, fill the gaps with rigid foam, and attach the panels right on top.
Section 4. Routing and running tubing. Next, we physically run the vanes of our system through the subfloor. This is where the actual heat delivery system gets locked into place.
Sometimes the pre-stamped channels don't perfectly align with a complex room shape. When that happens, builders use provided wood templates and a heavy-duty router to carve custom paths. Because, let's face it, real-world architecture often involves weird angles, kitchen islands, and complex plumbing penetrations. These specific templates ensure that any new channel you carve has the exact correct radius so your PEX tubing doesn't kink when you try to bend it around a corner. Now, working with PEX tubing is a very physical job. And let me tell you, trying to bend it in temperatures below 50 degrees Fahrenheit will fight you every single step of the way, because the plastic becomes intensely rigid. Once you're finally working in the right temperatures, you use a rubber mallet, definitely not a metal hammer, to gently tap the tubing flush into the channels. And again, absolutely no adhesives in the channels. You just seat it in, tape the open ends so no job site dust gets inside, and move on to the next section. Of course, accidents happen. If a tube gets punctured on site, it's actually a pretty easy 30-minute fix using specialized brass repair couplers. It happens to the best of builders, you know? Someone drops a sharp tool or accidentally drives a screw where they definitely shouldn't have. But instead of tearing up the whole room, you just cut out the damaged section, slightly widen the channel with a chisel to make room for the larger brass fitting, and lock the repair coupler right into place. And finally, Section 5, Hardwood Flooring Facts. We've reached the climax of our build, the final layer, and honestly, the elephant in the room when it comes to radiant heat. This part brilliantly busts the biggest industry misconception out there. There is this persistent myth that the heat radiating from beneath is what ruins and warps hardwood planks, but the manual clearly explains that wood is hygroscopic. That means it naturally reacts to ambient humidity in the air, regardless of whether your home is heated by a radiant floor system, forced air, or simply baking in the summer sun. The manual reassures us that a perfectly static piece of wood simply doesn't exist. Slate gapping is a completely natural, historical part of a home's character. Throughout history, way before modern HVAC systems were even a thought, wood floors expanded in humid summers and contracted slightly in dry winters. These microscopic movements are perfectly normal, and they're rarely even noticed once you're actually living in the space. So it leaves us with a fascinating question. If minor floor movement is just a natural part of history, is the invisible comfort of radiant heat worth redefining our expectations of a so-called perfect home? When you look at the sheer engineering that goes into these panels, the careful moisture testing, and the precise tubing layout, you realize you're building a floor that literally breathes and acts as an integrated system. It completely changes the way we think about comfort from the ground up. So what other invisible systems could we rethink to make our homes even better? Thanks for joining me on this deep dive into the blueprint of radiant heat.